Happy 4th of July, everyone. I have a bit of a new setup right now. Also just imported a ton of my books from work to my home. So yeah, that's pretty exciting. But happy 4th, and we're just gonna do some testing like we normally do. I was thinking about this puzzle a lot, the puzzle that OpenAI's o3-Pro was able to solve, and I'm thinking about giving the same puzzle to both Claude Opus 4 as well as Gemini 2.5 Pro, which are like the respective frontier models on those from those companies. I was thinking about, and there's me again. Sorry, I'm gonna post on X real quick. Let's see here. Okay, post that. Happy 4th of July, Euro. Good to see you, even though you probably aren't. You're in Europe, right? So people in Europe, I feel like don't celebrate 4th of July, right? Nevertheless, let's go ahead and get started with some puzzles here. I'm just going to go ahead and try and see how the respective models do here, Opus 4 and Gemini 2.5 Pro. Let me see here. I think we have the puzzle. If not, I can always just download it from here. Okay, I'll just take a screenshot of this. This is fine. Or we can save it, I guess. That works too. Okay. In the mirror, we celebrate July 14th. Oh, July 14th. Very interesting. I did not know that. Oh, thank you so much, Danilo. Thank you. I really appreciate it. Let me just make sure this image works. It does work. Okay, so we're just going to see how Opus 4 and Gemini 2.5 Pro also handle this puzzle. Actually, I'm going to turn off web search here, because it doesn't really need to search the web. But we'll have extended thinking on. We'll have Opus 4. Run that. See how that goes. And mentally, what are you talking about here? Oh, it's creating an artifact here. Displays the image and draws on, chose the solution path from the knight to the dragon. Okay, so it's creating an interactive solution here. It's pretty cool. I should probably put myself on the other side of this. We can see what it's doing here. Okay, let's see. How did it do? What? Click the show solution to the path from the next round. The red lines show the correct path through the maze. This doesn't even look like the right maze. What is this? What is this? Show solution. There's no way to get in or out of this maze. The nice into the maze to the bottom left corner. Move around. What? Okay. That doesn't seem to be at all what I wanted, but good try, I guess. What? Knight. Oh, I see. So there was knight and then dragon. And then it like drew this. Okay, so is this. Okay, well, first of all, this is not the right image. But second, would this have actually worked on the actual image itself? This doesn't seem. So you start. No. No, 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 no. Claude. Come on, Claude. Come on, Claude. Really? That's all you could do? I'm disappointed. So Claude created this artifact here. Maybe I could ask it to, let's see. Can you draw? Let's see. Try again. This time, use tools in Python to draw the red line through the maze without touching black lines. directly on the image. All right, let's try that. I'm probably going to be running out of prompt requests soon. I'm only on like the second tier of subscription for them, so I actually don't even know where to place my camera, honestly. Let's put myself up here a bit. I wonder if this is working. Oh, darn. I just realized I did actually... Darn. I did not put my Ethernet connection in. That should have done that earlier. Oh, well. Looks like so far we're stable for now. So I'm hoping that it stays that way. But if the stream gets laggy, let me know. I could also just connect with my Ethernet like I should have been doing in the first place. Are you excited by GPT-5? Yeah, definitely. I'm excited to hear. I'm excited to hear more about it and see what it will do. But I guess we'll just have to wait and see. Will it be AGI, as some people say, or will it not be? I don't know. Okay, so what did it do here? So I cannot directly access. Create a Python license, draw the line. Path on your maze. Okay, so it's drawing the math here. Hello, Eric. Good to see you. Good to see you. Let me see if I can plug in my Ethernet real quickly. This might just drop. This might just crash the whole stream. Oh well. Technical difficulties because Claude doesn't know how to like set things up before. Okay. Looks like we're still going. Looks like we're still going. Okay. Hello, MD Explains. Good to see you. All right, so what have we just accomplished, honestly? Did I just run out of tokens here? Okay, so okay, so draw the solution of the maze. Oh, here we go. Oh, sorry. Finally it loaded. Python script draws. Okay, yeah, I couldn't connect Claude. Show it's tryharding. Let's see here. Shows how to process your interactive HTML demo. Python solve maze. Okay. So, all right. So we have to just run that. Well, how about the HTML solution really quick? What the? Again, this is not the right maze. Well, this is not the right maze, but okay, there's also no exit on the right side of this maze. Show solution path. Okay, so it was like, well, I can't solve the problem exactly, but here is a completely different maze that has nothing to do with the original maze, and it's clearly wrong. So, okay, animate solution. That's cool though. At least it animates it. It animates it incorrectly. Okay, so that wasn't good. Let's see. Let's try the Python version that Claude provided here. Okay, so let's see if I can actually script this. me just get my Sublime text out there. I don't really know what you're referring to. It tunneled through the potential barriers. Oh, is that what we're talking about? I was kind of lost. So you're talking about quantum wave functions and quantum tunneling now? A quantum mechanical maze where you just have to go through it. There's just a non-zero probability you find the particle on the other side. So it's like, it must be quantum tunneling in that case, right? Let's just save this script as like maze puzzle. Maze solution pi. Okay. What is with my terminal? Okay, my terminal is here. Wow, I can't type. Download the solved maze. Okay, so I think we have to do Python 3 maze solution.py, and then what was the syntax for it? It's just put the name of the draw solution on maze. Okay, so we have to call this as draw solution on maze. So wait, draw solution. Oh, simple drawing path is equal to. Oh, okay. So do I just have to run it like here? And then put the sorry, trying to just figure out where to get the image here. Okay, can we run that? Is that actually gonna work or what? No, oh wait, we don't have NumPy on this thing? Okay, could I just run this in like Colab or something? Thought he was using Vim. No, I use Jupyter Notebook myself. I'm thinking of just going into Google Colab really quickly and doing that there. It's a weird combo of, it's a weird, Sublime has Vim mode. Oh, it does it now. All right, go to Colab. Let's just go here for a sec. I'm wondering, do I even have something here? Sorry, I'm taking so much time to figure this out. Just getting frustrated. Wait, what's the thing that I'm building with? What environments do I have on here? Call draw solution. Oh, okay. On maze. It's this image right here. Okay. That didn't work that good. That didn't work. So, all right. Based on what Anthropic's code did in the HTML, I'm not really that inspired to keep trying because this was not a good solution on this side here. I mean, first of all, I didn't even draw on the actual thing here. That's kind of funny. Well, in the meantime, let me just give this to Gemini while I also do this. Put this in here. Start creating media and la la la. Yes. I'll give it the same maze solving request. Do you think the IMO should be used as a benchmark? I mean, I was using it as a benchmark for a while. I think there's something though about like math and like formal logic that it's almost maybe not a good idea to try it with that, just because I think it can like regurgitate, like if things that have like formally defined systems of logic and like symbol manipulation to do it. Wait, where's the path? Where's the solution to the maze? What I was trying to say was that if it already has learned so much about the data of math that we have so far, I don't see it as being like a huge hurdle, because like, for example, Project Euler is something that it's been able to solve, and those are like really hard math questions that kind of just come out, don't have like known answers publicly available. And so yeah, I mean, it's getting good at being able to solve problems that basically high school students and smart college students can do. So I don't know if those are the right benchmarks to use. And you're back. Hello. You are back. So, sir, I'm going to have to ask you to not do that. And let me handle this really quickly. Gonna have to ask you to leave, sir. All right. Good. Okay, sorry, I had to delete some stuff here. Why temperature 0? I've just always felt that like with certain tasks that lower temperature is better in terms of not giving the not the highest probable thing. I guess that's more for like math and physics. I keep it more on like closer to 0 or exactly 0. But now I'm confused because I'm like, where is the... Let me try this instead. Let me turn off Wolfram for a split second here. And OneNote. Don't need those at the moment. I really just don't get this person, really. Yeah. He's on an alt. Okay, so sorry, we have a bit of a spammer going on for those of you watching at home or after the fact. Whoa, wait a minute. Did it? No, that was o3-Pro. Never mind. Never mind. That was I believe o3-Pro. Who solved this one? Wait, was this maze with solution? Oh, did that come from running the script? Oh, was that actually the result of running the script actually? Wait a minute. Sorry. I'm getting a little bit confused. Yeah, no, that was the solution of running it on the script. Oh, it's you again. I don't know how many times I have to put you away, honestly. Yeah. Yeah. I'm also going to just remove this person. All right, cool. Sorry. So I did run the script actually. So this was the script that ran. It said no. It said error, but it looks like me doing it did produce this solution. So sorry, this did come out. So this was the solution provided by Claude Opus 4, and you can see here it basically tunnels, does some quantum tunneling here. So not quite what we wanted. Not exactly, at least. So yeah, let's move on from that, and let's go back to Gemini really quickly. I wanted to try it just on the terminal here, and not the terminal, sorry, on the web browser here, and not the AI Studio. Okay, let's see how it does here. Oh, wow. Ah, you again. All right, so I'm going to have to ask you, sir. Yeah, to not be here. And I'm also going to put you in timeout. So there's been someone who's been spamming my stream pretty consistently since I ever started streaming here. And I've had to just keep putting them in timeout and reporting them and stuff. It's kind of annoying. Top dog on doctors. I want to mention that most of the problems I'm are proofs, which makes them struggle because a proof depends on the entire process rather than a correct final answer, which is more suited to RL. Okay, that's a good thing to know here. Started at the night. Well, there's no visualization here. Can you? Okay, maybe I should ask it to write a script. Write a Python script that will draw over image. Let's see here. Cheers from Paris. Hello, who's that? CM. Hi, nice to see you, CM. Thank you so much for stopping by. I really appreciate it. Good to see you again. And directly. Okay, so I'm actually just gonna ask Gemini to write the script. Sorry, I'm a little bit distracted, guys. There's just been a lot of spamming and stuff. I loathe Gemini Pro. Dang, loathe is such a loaded word, yeah? Why do you loathe it? I loathe it. Okay, so we're asking Gemini to solve this for us. Start near the right. Okay, this is the solution path, supposedly. Okay. I'm gonna try it with this. So, what's this script? What should I call this script again? Solve maze. Okay, let's call it solve maze.py. Works for me. And then change my terminal color. That's weird. Oh, I needed to solve it as... I trust Gemini, people are saying. Kyle, you have Hispanic roots, right? No, I'm Filipino, actually. I am Filipino. And let me go here, and I need to change the name of this thing to the actual image. Oh, shoot. There's too much stuff coming up. Okay, so let's try and run that. Oops. Oh, I don't have PILL. Is that really the thing? Yes, okay. What environments do I have on this thing? This is like my streaming account, so I don't really have that much to work with here. Do I have PIL in here? Python 3 solve maze. It did say spatial reasoning. We'll go and we'll get to the math and the physics soon. I did want to try and see how we would do this one problem that I've been thinking about. Let's see here. Yeah, top dog, underdog. Didn't you give us a question from before? Like some combinatorics question? Oh, okay. So it looks like, did it solve it actually? Here we go. Did it solve it? It did not solve it. Oh, dang. So that was Gemini's attempt. Okay. So Gemini and Claude did not do it quite right. So, all right. Now we get to actually do some math and physics, as people were asking. This was just sort of closing the loop on this, on these questions that I've been having, honestly, about these mazes and stuff. Let's see. So there's this problem that I was thinking about the other day, and I don't even know it's a good problem to give them. Don't even know if it's that good of a problem to give, honestly. Did you watch the alleged Grok 4 benchmark? Apparently it scored 45 on humanities last exam. Big if true. Wow. I did see some stuff about it on X, but I don't know how much of that I need to take seriously versus it just being kind of all hype. But heck, if it's true, then yeah, it's really awesome. Where is my Wolfram notebook? Oh, it's not loading. Oh, shoot. Oh, it went away. Sorry, I was too impatient. I think the rule is to not be too impatient. Then it'll actually get it done here. So I do have some... I have a lot of books behind me here. So here's this one. Been thinking about giving it something involving like circuits and things of that nature. And so, because I feel like for some reason it doesn't do a great job with like circuits, interestingly enough. Let's see here. So there's this interesting integral that I tried to study group theory and I failed. Yeah, group theory is not one of my favorite subjects either. Let's see. So let's do this integral here. Okay, so it's this expression, fraction. Where's the fraction? Okay, let's do, is it square root or is it squared? I think it's squared. So I think it goes w squared plus x squared plus y squared plus c squared squared. And then we go from 0 to infinity, basically. Sorry, what am I doing here? Infinity, infinity, and then I think you go from 0 to 1. This is kind of interesting. Oh, and then we have to do like dx, or so dw, dx, dy, oops, dz. Okay, so I think this actually comes out to something interesting. If it actually will run. Oh, it does not converge on 0 to 1. Pi squared 8 over z does not. Okay, wait. I thought this was something. Does this not converge? I thought this converged to something interesting. Well, that's the thing. With math, you kind of need to be able to linger on the basics for some time, right? I mean, or was it 1/2? Oh, was this a square root? I can't remember. What was the problem exactly? feel like I even took a picture of it too. That's not the right one. Okay, hold on. I'm pretty sure I took a picture of this thing because I was like interested in solving this problem. Oh, and of course it's on my other account. All right, let's see here. Let's get rid of the square root really quickly. It cannot be, oh, sorry, because it's an extra one. Really? Oh, it's 1 plus, oh, it was like a 1 plus that. Okay, wait. It was like that, right? What? Are we not doing that right now? Okay, the square root, but I think was this whole thing squared? Now I'm starting to remember. Sorry. I should have actually thought about it a bit more. Because I think this is squared. Because that would make sure it's... That should converge. Yes, okay, so that's pi squared over 16. Then if I do here... Eratosthenes, he's the one who predicted the... who calculated the radius of the Earth. Is that correct? If I'm not mistaken. Okay, so I had a twist on this. So this was basically the problem that I was thinking about. But then I had this problem in grad school for like a class that involved using Mathematica like this. And I was thinking maybe, just for fun, if that's what you want to call this, fun, you can play around with this. You can add another variable, squared, square that, plus that, and then, because it needs to be finite, so here we go. Like this actually is something that converges. Yeah, it's like 1/8 pi squared arc extension of 1. Kind of interesting. If you change this up a bit, you can get different numbers. I kind of just like playing with different bounds and stuff, and just seeing if it can actually solve this. I don't know. I thought he was an ancient Greek, if I'm not mistaken. So numerical value is 2.29. Okay, so let's see if they can do this problem. I kind of want to know if you could do this analytically, because this has a closed form solution. I don't actually know how to solve this analytically. It probably would just be very long and tedious and full of some substitutions, but I'm curious to know if these models can actually handle this kind of stuff. You could do quantum field theory integrals in Mathematica. In theory, yes, you could. Give it to O3. Okay, so evaluate this integral analytic. Both first do it analytically and find a closed form expression for close for the as an answer. Then perform the answer numerically and report the value of the integral to 2 decimal places of precision. Okay, let's see how this works. Jesus, that question looks cancerous. Well, you know, they're going to be okay, you know? They're going to be okay. They're going to live, okay? You know, we're not going to kill them with this. Though I'm probably going to run out of what you call it, requests on Claude Opus 4, because it's really like to take too many of these. But I think it's worth exploring. Have you tried Claude Code? I have not tried Claude Code. I have tried Google Gemini CLI. Why is this thing giving me... What does it say? Attach a higher resolution. No, that's pretty high resolution. I should be able to do it. Okay, give that. Just kind of curious. Oh, what? The integral of value. Wait, no. This doesn't get you pi squared over 8. Oh, times. Oh, pi squared times this? What? 3.726? No, it doesn't actually. Wait, that's not the answer. The answer is 2.29, not 3.726. Oh, yes. We may have been able to stump o3-Pro with some integrals. Let's go. Yeah, that's right. He was like, wasn't it like during during one of the solstices, and then he, like, when the sun was like the highest in the sky, like the summer solstice, and then he used like the angles of like two shadows made from two like different, like at two different cities, and then like used trig and geometry to work that out in terms of how massive the Earth was. Okay. Oh, wow. Oh, pi squared. Therefore, the final answer is pi cubed. Oh, pi cubed 1 over... Oh, it's not correct. It's not correct. It's not 1.18. It's 2.29. Yo. Okay, looks like we find a breaking point with these things. They can't seem to evaluate this integral. I mean, it only was like a, 4-dimensional integral it took, but it's kind of cool to see them kind of squirm a bit. Spherical coordinates. So where did it actually go wrong? Actually, this is kind of interesting, because clearly they're doing it wrong numerically. Yeah, no, quadruple integral is just the way to go when you want to stump these things. It's hallucinating. So we have 3 different answers. Well, 2 different answers so far. I mean, o3-Pro says it's 3.726. And what else is it doing here? Monte Carlo sampling. Okay. How is Gemini 2.5 Pro doing? Analytical evaluation. Oh, I saw the answer. It was not correct, but 1.80445. Is that the same one as this one? 1.18. No. The numerical value is approximately 1.80445. I've rechecked all my steps and I am confident in my result. So it does all that, does all that. And then we can do all this stuff here. This can be written as pi cubed over 32 arc sinh of pi 1.80. Yes, we have stumped it. We have stumped it successfully, guys. Integration. Let's go. I mean, in principle, we would not have an LLM do this for like a serious calculation. Probably just plug it into Mathematica, but it is kind of cool, I think, when you see these models try and BS you and be like, yes, obviously the answer is pi cubed 8 over 1 square root 1 plus pi squared, or it's, this expression, even though it's not. Got to give it credit. It's not using a calculator. It's doing symbolic manipulation as a form of advanced pattern matching. Yes, no, I mean, it's still really cool to see it even attempt to do this. I mean, as a human looking at this, I mean, I recognize there has to be some sort of, there has to be some sort of trig substitution and things of that nature, but it's just so ugly that I probably would just, not want to have to do it myself, honestly. It's very interesting. Give it the answer and ask them to work backwards. All right, let's see. Let's see it. Yeah, maybe we should do that. Let's go ahead and say, you are wrong, actually. Let me say, you are wrong. The correct answer is pi squared. I'll just write it as pi squared over 8 times arc sinh of pi. pi squared over 8 arcsinh of pi, which is approximately 2.30. Knowing this result, work backwards to identify where you went wrong in your mathematical derivation, and then supply the correct steps to reaching this final result. Okay, let's see how this works. So I gave it the numerical answer here. This is the answer. And so we'll see how it does. How is it thinking about here? Pi squared arcsinh of pi, yep. Different substitution. Okay. I might have made an error in my approach. I need to carefully recalculate the integral, focusing on pieces. Backtrack. When I evaluate the integral, I made an error in the calculation. Let me redo this step correctly. Let a equals 1 plus w squared. I need to evaluate this. Using substitution this. The integral becomes this. Therefore, this is where my error was. I had 1 plus omega squared to the minus 3 halves instead of 1 plus omega squared to the minus 1 half. Now the final integral of this and the antiderivative of this is this. So perfect. The answer is 2.30. Huh. Okay, so that's where it apparently went wrong. So how did it... Where was the 3 minus 3 halves? It had 1 plus omega squared to minus 3 halves. Did it actually have that in the previous one? It had omega... Oh, there's the omega squared. Plus that to 3. S is equal to... S is equal to 1 plus omega squared. The 3 halves is here. Oh, interesting. So it somehow... Was it here? It says when it used this substitution, it went wrong. So if you... That S is equal to 1 plus omega squared U. Jeez. Interesting. Are they gaslighting me? Yeah, I want to know, actually. Okay, so let me give the same thing to Gemini really quickly. Oh, sorry, that was the wrong thing. Okay, I want to give Gemini Pro, 2.5 Pro, the same thing. How did o3-Pro do? Okay, what did o3-Pro say it is? Oh, wait a minute. Oh, it got it! Yo! Oh my goodness. Oh my goodness. o3-Pro got the right answer. o3-Pro actually got the right answer here. That's crazy. Using sin integrate over w is equal to pi squared over 8 arcsinh that. Wow. Very nice, o3-Pro. Very, very nice. That's really good. That is really good. Okay, so let's see here. Let's see how Gemini is doing. Thank you. Mistake 1 over the third number perspective. I quickly squared the coefficient from the previous step. Here's the correct result. Integration. Correct. Let b squared. Oh, there's that 3 halves again. Trust o3-Pro. That's kind of what I'm getting the vibes from here. o3-Pro got it on the first try. Claude had to re-correct itself here. So, but why? But why did it do that though? Therefore, I of omega is equal to this. So the I of w or I of omega integral was this. And so what did it have? Yeah, it had this. And so it says let s squared equals 1 plus omega squared u. So if you write it like that, is that really what comes out? Is that how it messed up? So I just want to verify that. It says, now let s, so let's just write this expression down. 1 over 1 plus squared plus s squared. Okay, so you have that expression there. Now let s, let's take this expression, and then let s go to 1 plus omega squared times u. So when I do that, 1 plus omega squared oh, wait a minute. That doesn't seem right. Therefore, okay. So it should be that. No one can touch o3-Pro. Doesn't seem like it right now, does it? I do want to see something though with this, because I don't quite see how it did that. So it's supposed to have 1 plus omega squared to the square. Oh, okay, wait. Go back up here, and then therefore is equal to this. So this is off by a factor of a squared of 1, right? So this should be 1 plus omega squared, not to the minus 3 halves, but to the minus 1 half. I don't even understand why is it even, wait, why is it even under our root at all, actually? Yeah. Well done, OpenAI. Just throw compute at the problem. Yeah. So you have 1 plus omega squared, 1 plus omega squared. You factor out a 1 plus omega squared. And then you get... Yeah, so apparently it's right here. But I don't see where the I comes from. The I has here... It's from here to here, where you plug in 1 plus omega squared u, and then you have to somehow factor out... Oh, I see, because you square... You basically have one of those things. Okay, so I kind of need to have my OneNote here really quickly. That's an open conjecture right now, that one you just posted. That's a good one. Sorry, let me just go down here. I just want to, this is from a different stream, but I'm just going to use it here. So it said this basically. Give me a new page, please. Okay. Wait, so it says you have here root s over 1 plus omega squared plus s squared, and s is equal to 1 plus omega squared u, and then you have squared s over 1 plus omega squared plus 1 plus omega squared times u, and then you have all of that squared, right? Yeah, all that's squared. And so I think what I see here is that you need to basically take this. Okay, I'm just gonna call this, I'm gonna call this like C1, just to help me out with the math a little bit. This is what I do. Sometimes if there's an expression that I don't like because it's just long, I'll just like write it in terms of the shorting thing. Like C1 U squared. Why do I have that? Excuse me. Why is that 2 there? I don't know. Go away. What the heck? Excuse me. Why is that 2 there? Oh, now it's gone. So basically you have wait, I still don't get why that's the case. So we get the 1 plus u squared there, but how do you get oh, but s is equal to 1 plus squared. Oh, okay, so s is equal to 1 plus, okay, yeah, so s, so it's equal to this. S is equal to the 1 plus, I see. Okay, so it has that. C1, what did I call C1? C1 is 1 plus omega squared, right? So this is equal to square root C1 square root u over C1 squared C1 squared times 1 plus u squared. Okay, so yeah, this is where it messed up, I think. No, wait a minute, did that really? Is that really why it messed up? Because it says that, so C1 over C1 squared, that's equal to C1 to the 1/2 over C1 squared. So that's, oh, shoot. So it's 1/2 minus 4/2. That's equal to minus 3/2. Wait, so I don't get it. Wait, what? It said it had this. I mean, that is the right power you should have on 1 plus omega squared, but why did it say that it's wrong here? I just don't understand, sister. This I had 1 plus omega squared instead of minus 3/2. You know what I mean? Like, this was the right approach over here, and it's saying that that was its mistake. So is that just the wrong substitution, or like, ultimately integrals is with the power being minus 1/2 rather than initially assumed minus 3/2. But let's see. Okay, I don't know, to be honest, guys, why it's wrong, because technically it did that step right, but I just don't know if that was the wrong step in the first place or not. So anyways, interesting. How about Gemini Pro? Can we see what Gemini Pro came up with here? Well, why was it wrong? Okay, so it had pi squared over 32. Where did that pi squared over? Yeah, so it had the pi squared over 32 right here. So it says here this is a standard integral right here. So did it actually do this one wrong? So hold on. I just want to know if this integral right here was actually done incorrectly. So it's saying IY is the one I'm doing right now. So I just need to do this really quick. So here, infinity 1. Where's my integral sign? There it is. 1 dy c squared plus y squared. Then we have a pi squared over 16 on the outside. Pi squared over 16. And then what happens? Oh, come on. This should be standard Mathematica. So it does have pi to the 5 halves. Wait, what? Pi to the 5 halves over 32c. Wait, but I'm so confused because it's saying this factor of 32 is why it was wrong. But the problem is I don't, like, an incorrect coefficient of this. Let's c equals this. Here's the corrected step. The integrand is this. Iy is equal to this. Let's see. So this should have been 8. Oh, there's a 16 there. But like, why was the 16 there? Huh. I like integrals because you can you can, like, in principle just like figure out where the LLMs went wrong, and you can verify pretty quickly. Well, if you're not me, I guess you could verify pretty quickly, but I'm taking my time here to try and figure out like where exactly in its logic it went wrong. But yeah, I'm not so sure. Because it says I got this thing wrong because I had an incorrect factor of 32, right? It says here, like, I have an incorrect coefficient of pi cubed over 32. The correct coefficient is pi squared over 8, which is, like, where did that missing factor of pi come from? Pi cubed over 32. There's a pi squared and there's a pi to the 5 halves. Oh, so 5 halves, 5 halves. So wait, IY says the answer is pi cubed. Oh, whoa, wait a minute. Yeah, actually. So, oh, okay. I think I sort of see what went wrong here, because it says IY, which is this integral right here, which we just did. They said the final answer is pi cubed over 32, 1 plus 7 squared. So we're even getting the wrong factor of pi here. We are getting the right coefficient, but we don't get the right power of 5 halves there. So I'm inclined to... Oh, did I not evaluate that one correctly? Why is it not c squared? Let's just try that again. Okay, still, 1 over 32, 1 square root 1 over c squared pi cubed. Okay, no, it has the pi cubed right there. So it did that one right. So it was right here, but it's saying that this is the wrong coefficient, but it did this integral correctly. So that leads me to assume that either that was the wrong integral that they set up in the first place, or they did some math wrong later on, because it's saying it shouldn't have had the pi cubed over 32, but it did do this integral correctly, this one right here. So, yes, it should be c squared. People cut that on really quickly. Yes, thank you for catching that. But yeah, I think it did this integral correct right here. But it's saying pi cubed over 32 is the wrong coefficient to have, which means that that was probably the wrong integral to do in the first place. Or at least that's how I would interpret that, because I don't know how else to think about it like that. Because either it did the wrong integral, or it did some algebra wrong moving up. Yeah, I'm not so sure. Interesting. Very, very interesting. But we are coming up to the hour mark of my stream, and I was only going to stream for an hour today. So I apologize. I didn't realize we would spend so much time looking at like 2 problems with like the maze and just the integral. So please do come back next time though, and hopefully we can continue doing more stuff like this. I always just find it cool to watch these LLMs do integrals, even though of course we have tools like Wolfram Alpha and Mathematica do them for us. I do find it kind of cool to see them try and do these extended multidimensional integrals out and trying to figure out where exactly they went wrong in their analysis. So thank you again for watching, everyone.